Hello and welcome to lesson 2.2. So in last lesson we talked about parabolas. You were kind of introduced to the general form, which was y equals a times x minus h squared plus k. That is definitely something you're going to want to be familiar with. And basically changing a changes the parabola, and then changing h and k is going to change for the vertexes. So changing a can do one of two things. If you make it negative, it flips it, so it's going to be down like a frown. And if you make it bigger than 1, it's going to get what we call stretched. And if you make it smaller than 1, it's going to get compressed. Okay, so let's go ahead and fill this in. It says when the y values or the output values are multiplied by some factor, we say that the function has been, and the term is scaled. When the graph has become narrower, the function has been stretched. And actually, we'll do this in 2 colors. And when the function becomes wider, it has been compressed. So what they mean by that is we know our parent function, and we know that it looks something like this, right? X squared. So then when it becomes stretched, when it becomes narrower, it's going to look like that. When it becomes compressed, it's going to look like that. It becomes wider. All right. So next it says determine if each function will be stretched or compressed from the parent function. So what we're doing is we're looking at a, right? You can tell if it's stretched or compressed by looking at the a value, which is the one out in front. Okay. So this one's a 3. Basically, if the absolute value of a is bigger than 1, we get a stretch. All right, so this one is stretched. And what that means is that, again, if this was our parent function, our new function is going to be skinnier. All right. Now, number 2. Again, we have to look at the absolute value. So we're going to say, okay, what's the absolute value of negative 1/5? Well, that is less than 1. Okay, it's smaller than 1, which means that it's going to be compressed. So again, if this is our parent function, this graph will be compressed. And all of these, to kind of see the effect, feel free to graph on Desmos. You can see what all of these transformations do to the function. If you notice, these guys do have different h and k's, which means that the vertex is also going to change. So like for number 1, it would be 4, -2. So the function actually would get moved kind of like over here as well. It would be skinnier and the vertex would get moved. All right. So number 3. So pay attention to this because a lot of people get this messed up. So this is a fraction, but fractions can be smaller than 1 or bigger than 1, right? If it's an improper fraction, which means that the top half is bigger than the bottom, that means it's going to be bigger than 1. So one thing you can always do when you're given a fraction, just plug it into your calculator. Clearly 1/5 is less than 1. 5/4 is greater than 1. So this one's going to be a stretch. And here, we got the absolute value of -2. Again, we're looking at the absolute value, and that is going to be bigger than 1. All right, so this one is a stretch as well. All right. Okay, next it says, for each function below, determine the transformation, reflections, dilations, translations that must be performed on the parent function in order to graph the indicated function. Then identify the vertex, axis of symmetry, and complete a table. Okay, so first let's talk about the transformations. All right, so basically when you're talking about transformations, you're going to look at this guy, you're going to look at this guy, and you're going to look at this guy. Okay, first thing I would do is look at the vertex. We did this last time. So to find the vertex, You take this value, switch the sign, and then you just take this value. So this one would be 5, -7. Notice how I switched the sign of the x value. You always have to flip the sign of this guy. So that's the vertex. So I want you to think about if we started at 0, 0, and now we are at 5, -7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. We're there now, right? So what happened? Well, we went +5, down 7. So you could say we went to the right 5, down 7. All right. And then also we can look at our A value, right? Our A value, the absolute value of 2, is bigger than 1. So this one's going to be a stretch. You could say, if you wanted, like, stretch by a factor of 2. All right. So let's go ahead and plug points into the chart. Now, I know I'm going to get a lot of questions about how did you pick the numbers to plug into the chart. There's a lot of ways you can go about this. You could always just plug in, like 0, -1, whatever. What I would do is, that 5, since that's the vertex, right? The parabola is going to, open up around that vertex. So I would put the vertex kind of in the middle. So we have 5, -7. And then you can do 4 and 3, 6 and 7. I just feel like that, for me personally, I feel like this makes the most sense because then you get around that vertex. So all you're going to do here is plug in. So we're plugging in 4. So I'm just going to write out the first one so you can see what I'm doing, and then I'll put the answers in for the rest. So I'm doing 2 times 4 minus 5 squared minus 7. So then I get 2 times -1 squared minus 7, which just becomes 2 times 1 minus 7, 2 minus 7. We get -5. All right, so you have to do this. You have to plug in the x values. Of course, feel free to use your calculator. Just be aware of parentheses. So yes, you're going to plug in all those values. You should get -1, -5, and -1. So then once you get those guys, you can go ahead and graph them. So you got 3, -1, and then 4, -5, and 6, -5, and 7, -1. All right. So go ahead, graph those points. And that is your parabola. So you can see that that guy was definitely stretched up. I can even real quick draw the parent function. We have 1, 1, 2, 1, 2, 3, 4. All right, so like this is the original function. And you can see that this blue function is definitely skinnier. And you can see that we moved it down 7 and up 5. So you can see the transformations that happen there. All right, let's try the next one. So first it asks for the transformations. So we look here, and if you remember, I said the A can do 2 things. A can stretch or compress. And if A is negative, it can reflect. And what I mean by that is if this is our parent function, this is x squared, negative x squared, when you make it negative, it reflects it. Okay, so instead of being up like a cup, it is down like a frown. So, actually, I'll leave that there. So let's talk about the transformations. So we've got -1/2 as A. So first, let's check to see if we have a stretch or a compression. So -1/2, absolute value. If it is, this one is less than 1. So this one we have a compression, which means it's going to get wider. But then we also have a reflection, okay? The reason we have a reflection is because it's negative. So you could just say reflection over x-axis. And then for the vertex, you could see here that we have -2, 5. So what we ended up doing, you know, we normally start at 0, so we went -2, 1, 2, 3, 4, can't see, 1, 2, 3, 4, 5. So you can see that we went left 2 and up 5. So that completes our transformations. We had a compression because the A value was not 1. We had a reflection because the A value was negative. And then our vertex changed because we had numbers in H and K. All right. Ooh, and you know what? We skipped over the axis of symmetry on the first problem, so we'll go over that too. Sorry about that. All right, so now let's go ahead and write out our points. So again, I'm going to go ahead and put -2 in the middle, -2, 5, and then I'm going to put points around it. So we get -3, -4, -1, and 0. So now we're going to go ahead and plug in a point. Let's see, I will plug in -4. So I get -1/2 times -4 plus 2 squared plus 5. So then we end up with -2 squared, which is going to give us 4 times -1/2 plus 5, which is going to give us -2 plus 5, which is going to give us 3. All right, so you do that for all of the points. You get 4.5, 4.5, and 3. So then we can go ahead and plot our point. So I already plotted 2, -2, 5. So let's do -3, 4.5. 1, 2, 3, 4. And then we have -1, 4.5. So we can put that guy there. And then we've got -4, 3. And we have 0, 3. All right, so this is our function. It wasn't really parabola-y. I didn't draw it great. And one thing I've skipped on the last problem was this axis of symmetry, okay? It's not hard. All you do for the axis of symmetry is you take the x value of the vertex and say x equals, okay? If you recall the line x equals, they always go up and down. So really all the axis of symmetry is just saying, okay, this cuts my parabola in half. All right, so if you look back at this one that I forgot to do, the x value here is 5. So you would say the axis of symmetry equals 5. And you would put it in right here. All right, so now we're going to go ahead and we're going to skip a couple problems. So in class tomorrow, I'm going to give you some time to work on these problems, but we are going to skip 7 and 8. And you will have to do that during class, so if you want to pause the video and give them a shot now, feel free. Or you could just keep listening, and we will try 9, 10, 11, and 12. All right, so next it says, write the equation of each function in vertex form. So first off, what is vertex form? Well, that was, excuse me, y equals a times x minus h squared minus k. So we need to get it into this form, all right? So the h and the k come from the vertex, right? Our vertex is always h, comma k. So if we look here, our vertex point is -3, -7. So we're going to go ahead and plug those values in. So we've got y equals a times x, it's going to be x plus 3 squared minus 7. If you recall, you have to change the sign of that x value when you plug it into the formula. Then, what we're going to do to find out, we have to find a, and we don't know what a is. We can tell that a is definitely going to be positive, but that's about all we can tell from this. We need to go ahead and calculate it. So how you're going to do that is you're going to pick another point on this parabola. So I'm going to pick 0, -1. I picked that because it has a 0 in it, and quite frankly, I like working with zeros because I think they make my life a little bit easier. So we know this is an x, this is a y, so we're going to plug them in. -1 is y equals a times, and then our x is 0 plus 3 squared minus 7. So we've got -1 equals a times 3 squared minus 7. Negative 1 equals 9 times a. 3 squared is 9. Minus 7 plus 7 plus 7. We get 6 equals 9a. Divide by 9. And we can reduce. So we know a equals 6/9, which is the same as 2/3. So we're going to go ahead and plug that in. We get y equals 2/3 times x plus 3 squared minus 7. And that would be our formula. All right. So we're going to go ahead and try 10 and do that the same way. I'm going to go ahead and kind of minimize what I drew here so I got room for my other problems. So for 10, again, we have to plug into this y equals a times x minus h, or minus h squared plus k. That should be a plus. All right. So let's go ahead and we're going to plug in. So we can find our vertex. Our vertex here is going to be 1, 9. So we'll go ahead and plug that into our formula. We have y equals a times x minus, and our h is 1, that's our x value, squared, plus 9. Then what we're going to do is we're going to go ahead and pick another point on the graph. Let's see. I'm going to pick this guy here, 0, 7. I think he's a nice point. Again, I just like having zeros. You could pick other points here too. You could plug in 3, 1. You could plug in negative 1, 1. And you could plug in 2, let's see, what is that? 2, 7. Those are different options, but I am going to plug in 0, 7 because it is a 0 and I like it. So we're going to do 7 equals a times, and then my x value is 0, plus 9. So you get 7 equals a negative 1 squared plus 9. Negative 1 squared is 1. Make sure that when you plug that into your calculator, you use parentheses. And you end up with 7 equals a plus 9. You're going to subtract the 9. And you get a equals negative 2. Now this is important too. If you look, you can clearly tell that this graph is flipped. So you knew that a had to be negative, right? If it's down like a frown, a is negative. Think about it that way, right? If a is positive and happy, it's up like a smiley face. If it is negative, it is down like a frown, all right? And since it is, the absolute value of it is bigger than 1, it is a stretch, right? You can see that that's kind of a skinny parabola. So we'll go ahead and we'll plug this in. We get y equals negative 2 times x minus 1 squared plus 9. All right, so that is how you get it from a graph. Essentially, all you need to find the equation of a parabola is the point. So this is what you need. You need the vertex and another point. All right, so those are really the only two things you need. So now let's go ahead and look at number 11. So first off, I can tell that this is a quadratic. It's a parabola. How do I know it's a quadratic? Well, if you remember last unit, you can see that there's a common difference here, right? We saw how like when it goes down and then goes back up, that's most likely a quadratic, and that's what's going on here. We have a common second difference. So that's kind of besides the point. We're going to go ahead now and figure out how we come up with the formula. Now, how can you tell what the vertex is? The vertex is going to be the point that is in between, or I guess it's the point that's in the middle of kind of the similar numbers. So it goes 22, 12, 6. And then do you see how 5, 4 doesn't have a buddy? But then we have the 6 again, 12, and 22. Like this, we got these 6s, we've got these 12s, we've got these 22s. The 5, 4 is lonely. He doesn't have a buddy. So that's your vertex. All right, so we know our vertex is 5, 4. Now, we're going to go ahead and plug that in. We've got y equals, and then we don't know our a, and we know that our x is going to be 5, so you do x minus, remember you always switch the sign for the x, 5 squared plus 4. So now we're going to go ahead, and all you need to do is pick a point to plug in. So let's see, I will plug in, how about 3, 12. So this is going to be my x, and that's going to be my y. So I'm going to plug in 12 equals a, 3 minus 5 squared plus 4. All right, 12 equals a. 3 minus 5 is negative 2. So then I end up with 12 equals 4a plus 4. I'm going to minus 4, and I get 8 equals 4a divided by 4. A equals 2. So I've got my a, so now I just do y equals 2 times x minus 5 squared plus 4. All right, next one. So we're going to go ahead. Let's find our vertex, right? So you have to find the guy that doesn't have a buddy. So we'll go ahead, we'll look here. Now, if you notice, these two have a buddy. Do you see how this guy in the middle here does not have a buddy? That tells you that he is the vertex. Since he has two buddies on the side of him, he is going to be the vertex. And really what that means, right, if we think about like the way a parabola looks, you know that each one on either, each point on the other side, it's going to have a point that's kind of equivalent to it. All right, an equivalent y value. The only one that doesn't have an equivalent y value is the vertex. So you can see that this is the vertex because he is kind of smack dab in the middle, doesn't have a buddy. If you were to continue on, these guys would have buddies. All right, so yeah. All right, so let's go ahead. We've got our vertex, negative 8, comma, negative 2. We're going to go ahead and plug those in. So we've got y equals a times x, and then it's going to be a plus 8 squared minus 2. All right. And now what we need to do is find a point to plug into. So again, it doesn't matter which point you pick. It just can't be your vertex. I'm going to go ahead and pick this negative 7, comma 4. There's no rhyme or reason. You could pick literally any of these points. That's just what I chose. So we're going to go ahead and plug in negative 4 equals a times negative 7 plus 8 squared minus 2. We get negative 4 equals a times 1 squared minus 2. Oops. Negative 4 equals a minus 2 plus 2 plus 2, a equals negative 2. So we'll go ahead and we'll plug that in. We get y equals negative 2 times x plus 8 squared minus 2.